In today's lesson, we'll be looking at a more complicated example, but you will see if you remember your formulas for this series quite well, you can quite easily get to the answer. Now let's have a look. A convergent geometric series with only positive terms has a first term a constant ratio r, and the sum from term 3 to infinity is a quarter. Now, what's the question? If term 1 plus term 2 is equal to 2, write an expression for a in terms of r. So we want to rewrite this so that it contains a's and r's. So let's just see what we can do so far. So we write term 1 plus term 2 is equal to 2. And then we know that term 1 can be written as a, and there it is. Now we want to rewrite term 2 so that it also contains a's and r's. So we go to this general formula. Now why this specific one? Because we're busy with a geometric series. So the term in the unknown position is equal to a times r to the power of n minus 1. We want term 2. So in the place of this n and n, we are simply going to put a 2. So we've got term 2 is equal to a times r to the power of 2 minus 1. And then we can see that term 2 can be written as a times r to the power of 1. Now we do substitution of this and we simply go put it into the place of this term 2. And there it is. So now we have a plus a times r is equal to 2. And what do we do next? Since this is two terms and this is an equation, we want the terms on the left side to also become one term, so we're going to factorize. We take out a common factor a, and then we've got left a 1 plus r in brackets equals to 2. Now we want to write an expression for a in terms of r, so we want the a to remain here, and then we are simply going to take this 1 plus r and we are going to divide with it on the other side. So a is equal to 2 divided by 1 plus r. And that is all there is to it for this question. Now our next question is, what will the numerical values be for a and r? Let's go and have a look. Now here we already have the expression for a in terms of r, and we just calculated it earlier on in the lesson. Now the next question tells us, what will the numerical values be for a and r? So we have a convergent geometric series, so I'm going to make use of the sum to infinity formula, and that is equal to a divided by 1 minus r. Now, why this formula? Because it's a convergent geometric series. We add up to infinity, right? Now, what can we put into the place of the sum to infinity? Now, we cannot just simply put in a quarter because we have to read this carefully. The sum from term 3 to infinity is a quarter. So we are not counting from term 1, we are counting from term 3. So term 3 plus term 4 plus term 5 to infinity gives us a total of a quarter. But we also know that term 1 plus term 2 is equal to 2. So if we take this 2 and we add it to a quarter, we get 2 and a quarter. That means that will be the sum from term 1 to infinity. And that is the total that we want. So in the place of the sum to infinity, I'm going to put a quarter plus 2. Then we know that we are adding up all the terms from term 1 to infinity. And that is equal to, and in the place of this a, we can now put 2 divided by 1 plus r. And there it is. And divided by 1 minus r. Now we're going to do some algebra. So we can rewrite this as 2 and a quarter is equal to 2 divided by 1 plus r times 1 divided by 1 minus r. Now where did this come from? When we have a numerator and we divide it with a denominator, we can simply write it as a multiplication of that denominator's reciprocal. So we take this fraction and we basically just swap it around, and that's what I did. And then we can continue by simplifying this right side. So 2 times 1 is a 2, and then this bottom side we can simply say it's a product of two binomials. So a 1 plus r in brackets times a 1 minus r in brackets will give us a 1 times 1 is 1, and a plus r times a minus r gives us minus r squared. Now, this is a very important thing to remember, this product of two binomials, and there's the answer. So now we've got a 2 1/4 is equal to 2 divided by 1 minus r squared, and then we're going to get rid of this denominator by multiplying with it on that side. And now we have to remember, when we multiply this denominator with 2 1/4, this 2 1/4 has to be multiplied with both these terms on the inside. So we get 2 1/4 minus 2 1/4 r squared is equal to 2. Then we take this constant to the other side, and then we have minus 2 1/4 r squared is equal to minus 1/4, because 2 minus 2 1/4 gives us minus 1/4. And then we're going to divide with this coefficient. So we have r squared is equal to, and we have a 9th. And then we have to square root both sides, and then we have r is equal to plus or minus 1/3. Well, here they say we've got only positive terms, so we cannot have a negative constant ratio, so it's going to be a positive third. And that's it. So all that we do now is, now that we've got r, we take the r, we put it into r's place, and we've got 2 divided by 1 plus 1/3. And a is equal to 3/2 or 1 1/2. And that is it for now. See you next time. Bye.